Good day, ma'am. Good day, everyone. Today I'm going to discuss about the topic that were given to me entitled Ancient Astronomy. The ancient Greeks are sometimes referred to as the fathers of ancient astronomy in many older textbooks, devising elegant theories and mathematical equations to depict the glossaries of the cosmos, a phrase that, like so many others, comes to us from the Greeks. In truth, while the ancient Greek astronomers made significant contribution to astronomy, their knowledge was found on the firm foundations created by previous ancient civilizations in the Fertile Crescent and the barren desert of Persia, Mesopotamian and Zoroastrian astronomers and astrologers made numerous intricate observations and constructed complex hypotheses to explain cosmological occurrence. So, when Alexander the Great conquered the country in 331 BCE, this ancient wisdom fell into the hands of the Greek intellectuals who were hungry for knowledge. Because Greece was located at a major commercial crossroads, ancient wisdom from Indian Vedas and Chinese astronomers added to the Greeks' stock of knowledge. So, ancient astronomy and Hellenistic revolution. So, ancient Greek philosophers refined astronomy, dragging it from being an observational science with an element of prediction into a full-blown theoretical science. The ancient astronomers used astronomy to track time and cycles for agricultural purposes, as well as adding astrology to their sophisticated observations. So, they did not really generate any theories concerning astronomy and were more concerned with what was happening and when, without addressing the why and other than vogue attribution to gods and astrology. So the Greeks retained their beliefs in gods and omens, but they began to speculate on the universe's basic structure, asking why the sun, planets, and stars moved. Many of their concepts were ultimately enormous, since they were focused on theology and heavenly perfection. But the Greek philosophers were the first to try to come up with a grand universal theory. They attempted to discover the secret rules of the creation long before Einstein, Hawkins, and the great theoretical physicists who are descended from the Greek astronomers and speak the same mathematical language. So here, this is the epicycle, the solar epicycle. So in Hipparchian and Ptolemaic and Copernican system of astronomy, the epicycle from the ancient Greek was a geometric model used to explain the variations in speed and direction of the apparent motion of the moon, sun, and planets. In particular, it explained the apparent retrograde motion of the 5 planets known at the time. Secondarily, it also explained changes in the apparent distance of the planets from the Earth. Greek ancient astronomy and mathematical precision. So here, the ancient Greeks encountered the great civilization of Mesopotamia as early as the 11th century BCE, as they settled along the coast of Turkey. They also encountered the Persians and the Egyptians, absorbing customs and knowledge from these great cultures. As a maritime people, the Greek understood the value of reading the stars as an aid to navigation, and by the 6th century, ancient Greek seafarers of the Ionian culture could read stars like a map and understand the patterns and motions of the celestial sphere. So, if it hadn't been for the rise of the Greek philosophers, Greek astronomy might might have some um might have come to an end there. So if it hadn't been for the rise of the Greek philosophers, Greek astronomy might have come to an end there. Their unquenchable desire to decipher the universe undercurrents and interpret the ebb and flow of the natural cycles that regulate the earth in the heavens had turned into an obsession because of cross fertilization with Eastern cultures, and the Greek formed a pantheon of gods, but they were not happy with simply theological explanations for events, and they wanted to know how and why things work. Perhaps they viewed their beliefs as a way of reading the gods' minds and exposing what they regard to be nature's perfection. The Greeks saw the universe as a machine that operated according to mechanical and mathematical laws that could inferred through logic and reasoning. Ancient astronomers, Tales of Miletus, 624 to 548 BCE. So one of the first Greek ancient astronomers and the first notable Greek philosopher was Thales, who lived at the beginning of the 6th century BCE. A few written records exist, and the information about his work must be pieced together from the writings of the later philosopher. However, it is believed that he successfully predicted an eclipse in 585 BCE, although he probably repaired to Babylonian records for this. He is also credited with the inventing trigonometry, which is an early example of the strong link between astronomy and mathematics. Other discoveries attributed to him include measuring the apparent diameter of the sun and recognizing the significance of the star constellation Ursa Minor, the Little Bear, as a navigational aid for seafarers. Although it is difficult to tell from the source, it appears that he thought the earth was flat. Ancient astronomers, Anaximander of Miletus, 550 BCE. So Anaximander, another great early philosopher, better known for his ideas about the evolution, was the first Greek philosopher to create a cosmological model. He proposed a theory explaining how the universe worked and revealed that what he felt were the hidden process guiding the movement of the planetary bodies. Another great early philosopher, Anaximander, was the first Greek philosopher to create a cosmological model. He is best known for his ideas on evolution. He developed hypotheses that explained how universe functioned and showed what he believed were secret processes that guide the movement of the planets. So his greatest contribution was to envision the Earth suspended in space with the other celestial bodies forming circles around it. He also introduced the concept of depth to model, claiming for the first time that the heavenly bodies occupied three-dimensional space with varied distance from the Earth. The inhabited portion of the Earth was on top of cylinder, surrounded by an ocean, and it suggested that he believed the other flat surface of the cylinder included land, but he did not specify whether he believed it to be inhabited. So next is a ring of air encircled everything, followed by mist shrouded rings of the fire. He compared them with chariot wheels with hollow rims filled with fire and apertures in the wheels that led people to see the fire. The sun and moon were further away from the stars in his model, and the eclipses were explained by these holes becoming blocked. Of course, the appears to be a very backward way to looking at the universe to modernize. But we must remember that Anaximander had no idea of gravity and could think of no alternative model that would keep the sun, moon, and stars from falling to the ground. He never fully explained why the heavens did not revolve around the earth in a perfect circle, but instead rotated an angle, resulting in the seasons. Ancient astronomer Pythagoras, 492 to 572 BCE. Pythagoras, another philosopher better known for mathematics, also contributed to the knowledge of the Greek philosophers by postulating that the earth was spherical, a huge departure from Anaximander's model. He famously suggested his theory after seeing that when ships sail away, they vanish below the horizon. So demonstrating that the Earth's surface is curved. He also suggested that if the moon and the other heavenly bodies were spherical, then the Earth should be as well. Pythagoras considered spheres to be the ideal shape. Pythagoras was the first ancient astronomer to propose that spheres are in harmony and that the movement of the planets, sun, moon, and stars can be explained using the whole numbers and mathematical precision. So another of his discoveries was the morning and evening stars, Venus, are the same thing. Ancient astronomers Anaxagoras, 500 BCE, and Heraclides of Pontus, born in 388 BCE. So Anaxagoras is one of the first Greek philosopher that we know a little about, as he mentioned in the Greek history. This philosopher was admired by many Athens and counted the great Socrates among his disciples. He proposed various solutions to celestial phenomena and structure of the universe, explanations that would eventually see him vanish from Athens for heresy. He thought the sun was a massive ball of blazing metal, the size of the Peloponnese. So Anaxagoras also argued that heavenly bodies were made of granite ranged from the earth and lit blaze rapid rotation, implying that they were far away from us and so unable to be felt. So finally, he thought the moon was a world similar to our own, complete with valleys, mountains, and ravens, and speculated that it might be inhabited. He went back to the ancient theory of flat Earth, claiming that strong winds blew beneath it, causing causing it to ripple and generate earthquakes. Heraclides was the first to propose that the sun was the center of the universe, an idea that would not be recognized until over 2,000 years later. When Copernicus proposed it, Plato, one of the prominent Greek philosophers, was influenced by these two ancient astronomers. Ancient astronomers, Plato and the crystal sphere. So, was a philosopher who believed that explanations could be deducted through reason. Plato believed that the entire cosmos was constructed with precision and that the circles and spheres, as the most perfect objects, were the key to understanding the universe. His contribution to ancient astronomy was the idea that the stars, sun, and moon were fixed to concentric crystalline spheres, rotating inside one another. The stars, according to Plato, formed the outermost crystal sphere, which was followed by the planets, the sun, the moon and the spherical Earth in the center. However, records and observations quickly revealed that this model could not properly explain the intricate movement of the planets, sun, and the moon around the fixed Earth. This move at varied speed across the sky, frequently appearing to move backwards in relation to the sky and retrograde orientation. Plato, over the implicator, concluded that while the movement was still circular, his model required a little more complex explanation. Exodus, a student of Plato, envisioned the universe as having a static Earth as its center and stars in outermost crystal sphere. The sun circled around the Earth at the same rate as the stars inside the sphere, but it was also tied to a sphere and rotated once a year around this axis. So this would also explain why the stars do not circle the Earth on the same plane if the solar sphere were connected to 231 by 2 degree inclination. The difficulty with this is that it did not adequately present all the intricacies of the sun's motion. Thus, exospheres were added to Plato and Exodus model. The model needed at least 55 variables to count for the movement of the moon and planets. Ancient astronomers Aristarchus, Erastus, and the celestial distance. Aristarchus, teacher of the better-known Archimedes, was the first astronomer to make a reasonable estimate of the distance of the sun and moon from the Earth. He proposed that the universe was far greater in size than suggested by earlier philosophers, believing that the Earth, lying at the center of the universe, was tiny compared to the sphere of the stars. As a result, this huge distance explained why the stars do not appear to move relative to each other. He also proposed, along with Eratosthenes, that the stars and sun did not move in the sky, instead believing that the Earth rotated around its axis, albeit this notion was not widely accepted. Ancient astronomers Hipparchus, Ptolemy, and Epicycles. The problem with the idea of concentric sphere was that it did not The problem with the idea of concentric spheres was that it did not explain the full complexity of the planetary motion, and the model could not explain how the moon and planets varied in size and brightness. Hipparchus, in 2nd century BCE, was the first to suggest a new model to explain this and suggest why the seasons varied in length. Hipparchus believed that the Earth did not lie at the very center of the universe, but lay slightly off the center. Ptolemy took the idea furtherly expanded upon the idea, proposing the famous theory of epicycles. Hipparchus and Ptolemy invented the concept of epicycles, in which the sun, moon, and planets orbited the Earth in circles but rotated in the smaller circles inside each cycle, using trigonometry. This fully explained the moon and planets' occasional retrograde motion, as well as why the sun and moon were sometimes closer to the Earth and hence larger. And observations demanded more complicated hypotheses. Ptolemy constructed circles within circles, eventually becoming as complex as Plato's crystalline spheres. This is an unfair critique because, given the information he had at the time, it was a reasonable explanation for the structure of the heavens. He adhered the paradigm with tenacity, failing to make the initiative leap that later astronomers like Copernicus could have to make. The ancient Greek philosophers were both blessing and a curse. to astronomy. On one hand, they made accurate measurements and moved the idea of the structure of the universe away from gods and superstition. Ancient mathematicians used geometry to create models, and the philosophers used the idea of harmony and balance to describe the underlying motions of the universe. This idea of perfection could, could influence astronomers for centuries, with the Muslims and Renaissance philosophers seeking to understand the balance of the divine universal perfection. This idea of precision is based on Newtonian physics, and it wasn't until quantum physics, Einstein, in chaos theory, that the view was severely challenged, and the people began to accept that the cosmos may not be perfect or possess universal harmony. On the other side, the Greek ancient astronomers' geocentric paradigm and epicycles endured for another 15th century, perhaps encouraging modern theoretical cosmologists to go down the wrong route following the fall of Rome. The ancient astronomers' expertise passed into the hands of the Islamic academics who retained the Greek knowledge while adding their own theories. That's all, ma'am. Thank you for listening.